Hi there, welcome back to this channel. Now, since we have already learned in the previous videos, hi there, and welcome back to this channel. Since we've already learned that in the previous videos that color does not come from the material, that is, the color that a material or a body bears does not come from the body, but actually comes from the um, light frequency that is reflected by the body, or that our retina perceives, which is of course the one that is reflected by that body. And that is where color comes from. All right, so it is expedient to understand that so that we can understand how colors are actually formed. So, and in order to understand how colors are actually formed, we must understand the two types of colors. We have two major um, types of colors, and they are now categorized differently. We have the primary colors, and we have the secondary colors. Now, before we learn those two, we'll discuss these two. You should remember that I said that it is the rugby that come together in equal intensity to give you the white light. So white light is equal to the combination of all of this. But we must also know that it is not only this rugby spectrum that gives us white light. Whenever we combine the distinct frequencies of light, including the red, green, and blue wavelengths of light, we make the white light, or the white light is derived. So for example, what that is saying is that when you add green light plus red light plus blue light in the correct intensity, I told you that the intensity matters. The intensity matters. So if you add red, green, and blue light in the correct intensity, you're going to get what? White light. So that is what? Color addition. So that gives us color addition. And you see these three colors that gives us white light are called what? Primary colors. So those are the colors that when we add them together, because they are distinct, they give us what? The white light. All right. Then secondary colors are the colors that we derive from from the addition of any two primary color. So primary color add up to give white, and then secondary colors are the ones that that are any two combination of the primary colors. All right. So with that, we come to what is known as the color triangle. The color triangle. Now, this color triangle is going to help you to understand the addition and subtraction of colors. So we have R here. We say RGB and YMC. Okay, so Y standing for yellow, of course, and M standing for magenta, and C standing for cyan, B for blue, G for green, and R for red. All right, so what this is saying is that we've already learned that when we add RGB, which are our primary colors together, when you add these three that are the edges of this triangle together, you get a white light. You get white, which we said is not a color, of course, we said is just a combination of all the colors, right? Because it is not a wavelength of the light, right? So white is gotten from R, G, and B. Now, how do we get magenta? Magenta is simply the combination of red plus blue. Do you understand? So when you combine red and blue, you get magenta. Do you understand? So magenta, therefore, is not a primary color, but a what? A secondary color. Magenta is a secondary color. All right. Then we also have green plus blue. So green plus blue will give us cyan. So cyan is also a what? A secondary color, because it is gotten from the combination of two primary colors. Then green plus red will now give us yellow. Green plus red in the correct intensity will give us yellow. And yellow is also a what? A secondary color. Right, that is correct. That is it. Now, when we now combine these primary colors, what do we get? When we now go further to combining secondary colors. Now, what if we combined a secondary color plus a blue color? Now, what are we going to get? If we combine blue plus this secondary color, yellow, we are going to get white. If we combine red plus cyan, we are going to get white also. If we combine green and magenta, we are also going to get white. This is the reason why they are called complementary colors. They are called what? Complementary colors. So complementary colors are colors that when you add together, they always comprise of a secondary color and a primary color. So they are colors that when you add them together, they always give you white color. Um, 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 in as much as you combine them in the right intensity. So this guy will give us what? A white color. These guys will give us white color. So we say they are what? Complementary. When two colors add up to give us white light, so they are said to be what? Complementary. Complementary colors. All right, now let's get to color addition. So we've learned so far color addition. So what we've done so far is in fact color addition. So that when you add these, we know the various combinations that can give us white light and what the rest gives us. All right, what if you decide to add yellow plus cyan plus magenta? And I hope you understand why this gives us white. All of this gives us white. You know that yellow is already a combination of red and green that is not here. So blue RGB gives us white. So, and GB gives yellow, right? I mean, GB gives cyan. GB gives cyan. So it means that red plus cyan must be white then. Red plus cyan must be white. Does that make sense? If I say that, so as I was saying, that if this green is a primary color, you combine it with magenta and it gives you white because magenta is a combination of R and B, red and blue, which are already primary colors to give this. So that's why this will complementarily give you white. All right. But what if you combine the three complementary colors? You're going to get. If you combine the three complementary colors, you should get black. You will get black. All right. So that's about that. Combine the three secondary colors rather, you're going to get black. Three secondary colors give black. Now, what about color subtraction? Color subtraction. Now, color subtraction is very expedient in understanding how we see things. Excuse me. Now, how we see things. Now, for example, what this is saying is that if a shirt appears red, it means that it is capable of absorbing the red. If we call it a shirt, now let's not talk about the appearance. Let's learn what the appearance will be. Now, what if a shirt is capable of absorbing the red wavelength, the red frequency of light? If it can absorb red frequency of light and white light is incident on it, what color would it show? So if white light is incident on a shirt and that shirt can absorb red, it contains atoms that are capable of absorbing red. Now, what color would it show? It's basically the white light minus the red because it's going to absorb red, and white is already R plus G plus B. So if you subtract R from that, R goes away, and what you have is G plus B. And what is G plus B? What you have is what? Cyan. So it means that cyan is the color that shirt will exhibit, will show. Do you understand? So the color that we're going to see is cyan because when you shine white light on it, it's going to absorb only the red frequency. Now the same way, if you shine the same white light on the shirt that can absorb blue, it takes away this blue. The red and green are going to be emitted, and red and green gives yellow. So the shirt is going to appear yellow. So you see a yellow shirt because red and green wavelengths are the ones, or red and green frequencies are the ones reflected, but blue is being absorbed. Does that make sense? All right. What if on that same shirt that can absorb red, on that same shirt, a cyan or a magenta light is shown on it. The magenta light is shown on a color on a shirt that can absorb red. So what happens? First, how is magenta formed? We say magenta minus red. Remember that magenta is what? Magenta is R plus B, right? So we say R plus B. So that is magenta, then minus R again. So this takes care of this, and the color you see is what? B. That is blue. Do you understand? So that is how simple color addition and subtraction is. That's how simple color addition and subtraction is. All right. So it therefore means that if a shirt can absorb blue light and and a yellow light is shown on it, let's solve that. If a shirt can absorb blue light and a yellow light is shown on it, what color would you see? A yellow light is shown on it. Now that is yellow basically minus blue, right? Now what is yellow? Yellow is a combination of red and green. Is that okay? Then minus blue light. So now seeing this, there is no subtraction of blue light here because blue light is not a part of this. So what that basically means is that you're going to see black. You're going to see black. So the same way, if you shine, but if you had shown something like magenta on a shirt that can absorb the blue wavelength, remember that magenta is already red plus blue. So then minus blue, then the color that will be shown is what? Is red. All right, so that's simply how to do color addition and subtraction. That will be all for this video on colors, color addition, subtraction, and all that. Okay, there is something more. There's something more about color filters. Now, color filters are substances that can absorb only their color filters are substances that can absorb only their colors, or only their own frequency. So, for example, if I have a red color filter, and I shine white light on it, on a red colored filter, so it will be subtracted, it will absorb red. Is that okay? Then we'll transmit the remaining wavelength. So a color filter absorbs its own frequency and transmits other frequencies. So what that is saying is that if a white light is shown on it, then it will absorb red, and then green and blue will be transmitted. Then the color you see here is green plus blue color, and that is cyan. So the color that will be shown is what? Cyan. All right, and that's all on color subtraction and addition. See you in the next video, and do well to like and share this video with your friends. If you have any question or concern about the content, the topic, do well to leave them in the comment section. I'm going to answer them as soon as possible. Thank you, and God bless you.